Hello, I'm Dr. Gerald Lewis. I'm a cardiologist, but also a general physician, and like many of my colleagues, I've become increasingly dissatisfied on how we're helping our patients, particularly those suffering from today's chronic degenerative diseases. And what I'd like to talk about today is fatigue and failure, how we can help our bodies cope more. What can we do when our energy system, the demand, exceeds the supply? Now, the energy system in our body is very important. Our bodies need energy. If we haven't got energy, we slow down, or eventually we die. In many of today's diseases, the system is just simply failing. Patients with chronic fatigue, fibromyalgia, heart failure, emphysema and lung diseases, multiple sclerosis, nerve diseases, arthritis, immune diseases, cancer, fatigue and weakness, lack of energy are present in nearly all of these and many other diseases. And unfortunately, modern medicine ignores it. We focus in on the disease, but we don't focus in on how our patients feel and just how tired and lethargic they are. And it's unfortunate, because treating energy problems in some cases can actually cure the condition. It can certainly help the body to fight the disease. It'll make our patients feel and cope a great deal better, and it may prolong and improve the quality of life. Hippocrates said primum non nocere. In fact, he didn't say that because he was a Greek, not a Roman, but nevertheless the statement was made by him: first do no harm. And unfortunately many medical treatments can in fact do harm, so we don't want to make it any worse. But what I'm going to talk about in the next 15 to 20 minutes, treating the energy problems properly, can only do good. We can do no harm but good. Now, our bodies are a wee bit similar to a car engine. And for most of us, all we need to know is the very simple facts. We get in the car, we put the gas in the engine, turn the steering wheel, press the pedal, the engine makes a noise, gas comes out the exhaust, and the wheels go round. And for most of us, that's all we need to know about running and how our car works. And sadly, unfortunately, the medical approach to fatigue is very, very similar. But we all know that a car is a great deal more complicated than that diagram shows. And our bodies are similar in many ways to a car engine. Fuel goes into the tank at the back. It's taken by an engine to the engine by pipes, the fuel pipes. The cylinder is mixed with air. In the cylinder, the fuel is mixed with air. The spark plug fires, and the mixture explodes. And this energy then pushes up and down the pistons. These turn the crankshaft. This goes down the line shaft to the wheels, which then turn round. So that basically is why how our cars work. Now, our bodies are quite similar to that in many ways. Fuel, we use sugars, fats, and protein as our fuel, and we get that in our food. That food we take at a meal, and it goes into our digestive system, through the little villi in the intestines, and into the bloodstream, which are the little red lines there, the arteries in the veins. The arteries then take the nutrients to the cells, a bit like the fuel pipe takes the fuel to the cells. Arteries go all over our bodies, to our gut, to our heart, and to our brain, in a very dense network of blood vessels. And they finally end up in the cells all over our bodies. We've got trillions of cells, all of which working together to make our systems work. Now, inside the cells are things called mitochondria, and the mitochondria are a wee bit like the centre of the centre of the engine of a car. In the mitochondria, that's where we burn the fuel, the sugars and the fats, and they're burnt, creating energy, and this energy is then taken out of the mitochondria by a very complex system to where it's needed. Let's, in this situation, say it's the muscles in the cell. So let's look at how our bodies create and distribute energy. Now, it may sound a little bit complicated, but stick with it, because I think you'll find that in the end of it all makes sense. But more importantly, it does make sense in helping our patients. We burn fuel, sugars and fats, and the central system centered around our cells is the Krebs citric acid cycle, which doctors all learnt when they were at medical school. Complete waste of time learning all the parts of it, but nevertheless we did. And what happens is sugars and fats are converted into something called pyruvic acid, which is there, and that adds 2 more carbons to the energy, and then that goes around the citric acid cycle. And as it goes around the cycle, it releases the energy. These little yellow squares with NADH are energy. The NADH is released as energy, and this is then transferred to something called ATP, which is what we use to transfer energy with. And each loop of the cycle creates 36 ATPs. So what happens is pyruvate comes into the top, this is a mitochondria, pyruvate comes in the top right hand corner, it goes through all the various pathways, and then out comes carbon dioxide, water, and ATP. And all this happens in the mitochondria of our cells, right there. And the energy then needs to go from these to where it's needed, either the nerve cell, the muscle cells, the bone cells, the gland cells, the blood cells, or the reproductive cells all over our bodies. Now the muscle need lots and lots and lots of energy, so muscle cells have actually got lots of mitochondria. They're stained purple in this one, but basically this is a muscle cell with lots and lots of mitochondria all over the muscle generating energy. And what happens is the mitochondria, that little orange thing down the bottom there, that burns energy through the cycle, the Krebs citric acid cycle. Then the energy is released through the wall and out into the muscles, and the muscle can then use the energy, and then it works. And coenzyme Q10 is essential to move the electrons out of the mitochondria. Coenzyme Q10 is there. Basically, the electrons have got to go through the mitochondrial wall, and it needs coenzyme Q10 for that to happen. So just as a car needs all the components to work and to move, the body needs all the energy components to work properly as well. We need fuel, sugar and fats. We need oxygen. We need all the components of the Krebs citric acid cycle. We need coenzyme Q10 to enable basically the energy to get from the mitochondria to the muscles. So what happens when we're sick? First of all, nearly everybody who's sick loses their appetite, and we eat easy foods, not good foods, but the easy foods. We also take drugs which affect our metabolism. For example, the statin drugs. I'll just stop for a second just look at what statin drugs and many other drugs do. They do more than just lower the cholesterol, which is what they're used for. This is the pathway of statins from HMG-CoA down to cholesterol, which is down there at the bottom left-hand corner. And the statin drugs block that pathway up there, HMG-CoA reductase. They block that enzyme. But unfortunately, they also block, in addition to blocking the production of cholesterol, they block selenoproteins, which is where selenium is used. And that can cause myopathy, which is muscle problems, and also problems with our thinking. It blocks coenzyme Q10, which is essential for energy. We've talked about that. It blocks the tau proteins. An increase in tau proteins increase the effect of Parkinsonism and Alzheimer's disease. Heme, which is an essential component of hemoglobin, and myoglobin, which we need for energy, both in blood cells and in muscles. Delocol, which is essential for the synthesis of proteins in the cells, and many, many other things. So basically blocking that to stop cholesterol has all sorts of other effects. And is it surprising that people get so many side effects associated with the statin drugs? Unfortunately, many of them are subtle and somewhat unnoticed, and therefore we tend to ignore them, or we don't realize it's the statin drugs that are causing those side effects. So back to where we were, we take drugs which can affect the metabolism, and we become weaker. Is it surprising? And the answer is so simple. When we're sick, we need to give the body all the nutrients it needs to function as well as it possibly can, both to feel better but also to fight the disease. So how can we keep our energy system working well? Number one is we eat as well as we possibly can, especially fruit and vegetables, fish, and some red meat. All of those are important. We're designed to eat all of those in our regular diet. If you're a vegetarian, you probably need to eat a lot more things containing calcium, iron, zinc, B12 and vitamin D, or alternatively take a supplement as well. Do regular exercise. It's important to exercise on a regular basis because that gets the system gently turning over. It's a bit like a car. Run it regularly every now and again. It's good for the engine and it's good for our bodies to exercise. If you don't want to exercise, get a dog and take the dog for an exercise. And people with arthritis and things like that often find they can exercise better supported by water. Not too hard, but a little bit of exercise for everybody is beneficial. Supplements. We need to supplement the foods with the quality products which give body all the nutrients that our bodies need. We need to make certain that our body's cells have got all the nutrients they need to work properly. We need a good multivitamin and a multimineral. This is a slide of some of the chemical reactions that occur in our body. Now you can't see this, and nor can I, but it does show the incredible complexity, but it also shows how many different elements and compounds and vitamins we need for our body, and a good multi will provide most of that, provided it is a good quality product. Vitamin D, the sunshine vitamin, we need vitamin D. It comes from the sunshine. A little bit comes from food, but most of it comes from the sun. We've got vitamin D receptors in every cell of our body, and low levels in people with heart have been noted in people with heart disease, heart failure, chronic fatigue, multiple sclerosis, cancer, bone diseases, immune diseases. We need vitamin D. We're only just realizing just how important vitamin D is as well. We need plenty of calcium and magnesium, 400 milligrams a day of both of those, because calcium and magnesium are essential for muscles to work. When a muscle contracts, what happens is calcium moves in, magnesium moves out, and the muscle contracts. And then when the muscle relaxes, calcium moves out, magnesium moves in, and the muscle relaxes again. Now, if you haven't got enough calcium, it doesn't contract as well. But most importantly, if you haven't got enough magnesium, it doesn't relax as well. So basically, the muscles need lots of calcium and magnesium. Omega-3 fish oils, omega-3 fish, it's basically omega-3 means that the third carbon has got a double bond there. But basically, these occur in fish oils, and they're very, very important. Omega-3 oils are absolutely essential for many hormones, for cell walls, for nerves, and for our cell function. We need fish oil, omega-3 oils. Coenzyme Q10, we've talked about that. It's absolutely crucial, because what happens is fats and sugars burn in the mitochondria, but they can't get out. The energy can't get out unless you've got coenzyme Q10. And then there's the coenzyme Q10. It basically is fat soluble, and it takes the energy out of the cells and then goes back and picks up more. So coenzyme Q10 is absolutely crucial. L-carnitine. L-carnitine is an essential component for getting fats to the citric acid cycle. It carries the fats to the mitochondria to start the process. Now, L-carnitine is made in the liver and the kidney, but under stress and under disease, the need may outstrip the supply. So even though we've got the nutrients, they can't get there because of lack of L-carnitine. And finally, D-ribose. D-ribose is the essential backbone molecule of DNA. DNA is deoxyribose nucleic acid deoxyribose, which is D-ribose, and RNA is ribonucleic acid. So basically, it's an essential backbone for DNA, but it's also part of ATP. There's the ATP molecule there, and if you look in the middle there, that is ribose. So ribose is absolutely essential for our DNA, our RNA, and also for ATP. We can make ribose in our bodies, but if we're sick, often the demand exceeds the supply, and the system doesn't work so well. So when we're sick, we lack many of these energy necessities. First of all, we don't feel like eating. Hospital food is not very appealing. The disease process can actually eat up quite a lot more than themselves. We rarely see the sun. In fact, the sun going through through a window, for example, gets rid of the ability of that sun to create vitamin D. Our liver, kidney, and other cells aren't manufacturing these compounds as well as they possibly could, and some drugs interfere with their production as well. So is it surprising that tiredness and lethargy play a part in almost all of today's chronic diseases? The answer is so simple. Eat as well as you possibly can, regular exercise, and supplement a good multi, a gram of fish oils, 4,000 to 8,000 units of vitamin D, 400 milligrams of calcium, and 400 of magnesium, 100 to 300 milligrams of coenzyme Q10, 1 to 3 grams of L-carnitine, take it in the morning at night, and D-ribose, 7 to 10 grams a day. Now, all of those are not very expensive, but more importantly, they're relatively easy to take. The adverse effects for those is absolutely zero. The benefits are potentially immense. So if you've got any illness causing tiredness, lethargy, or failing cells, heart failure, or other cells that are failing, chronic fatigue, there's absolutely nothing to lose and everything to gain by taking these supplements. Thank you for listening. That's my website if you'd like to go to it. I've got videos on other talks as well. Thank you for listening.